Hi everyone, I'm Tomer Ganor. I'm Tomer Ganor, working at Certora for 3.5 years, a security researcher, and I'm here to talk to you about Lido v3, securing by design. So let's start. So why should you trust me? I've worked on all of these protocols. They trust me with the security, especially Aave, Lido, Balancer, Silo, which I did the design review for, which means basically that I audited their design, security design. Aave v4, Lido Door Governance, Lido v3, Balancer v3, and also the latest version of Silo. So let's start. So what is Lido? My journey with Lido started in Lido v2 when it added the withdrawals. And from my experience, the Lido team really cares about security. They really value it, and whatever small issue that I told them, they fix it immediately. Thoroughly, completely fixed it. Not small fix, just deals with the problem, or just say, no, it's a low issue, we don't care. And we'll see here also how they really, really care about security. So Lido is a liquid staking protocol that you deposit your ETH. It goes to the consensus layer, and the Lido stake it, use validators, get rewards, and you get a portion of those rewards, 90%. You deposit ETH, you get STETH, yield-bearing token, and that's it. Very simple. But the problem that we have with Lido Core is that institutionals can't use it. The reason that institutionals can't use Lido Core is because when institutionals want to deposit their ETH to the Lido pool, to the Lido Core, their ETH mixes with everyone else's ETH, maybe dirty ETH, maybe ETH from money laundering scheme, maybe ETH from terrorists, maybe ETH from a bunch of different entities that they don't know. And institutionals just can't make... Oh, sorry. A second. See the screen. Sorry. Oh, great. Sorry. So institutionals cannot get their ETH mixed with dirty ETH from regulatory perspective, from compliance perspective, and they just need to have the ETH isolated from everyone else. So if institutionals want to stake their ETH, they can just stake it like any solo staker. But if they do it, if anyone wants to withdraw, wants to exit, let's say ETF or a bank or sell their ETH, they can't just sell it because it's in the consensus layer, which means they need to wait until the exit queue clears, until they can withdraw their ETH, and only then they can sell it and repay, exit the user they want to exit or the trader or whatever. And they can't stake their 100% of their ETH because then they couldn't repay immediately to the user. That's a problem. Because if you stake only 50% of the ETH, and let's say in Lido you can get 3% or 4%, you get only 50% of that 3% or 4%, which is less yield than what you want. You want to stake your ETH fully, you want to get all of the rewards, and you want to profit. So how Lido v3 solved this problem is by letting the institutionals just do the same as solo staking, but with extra benefits. So they take their ETH, deposit to the staking vault, which is just an isolated vault that they control, and they get stake from there. Up until this point, it's exactly the same as just solo staking. Just take their ETH, put it in the staking vault, isolated, and stake it. Then, after that happened, they stake everything 100% of their ETH. And if any user want to withdraw, to cash out from their position, what they can do is they can just borrow STETH from Lido, mint it directly from Lido, sell it in the market immediately, get the money to pay the user, they pay him, and then initiate the withdrawal for the required number of validators they need to withdraw. When they do it, then they will wait the amount of time that will take, let's say, a couple of days, maybe a couple of weeks. Currently, I think 2 months ago, it was like 60 days they need to wait, but now they could repay the user immediately, so they don't care. Then when the money comes back, they could repay their debt, and that's it. And they don't care about this time that passed. Maybe they need to pay a bit more for this extra yield that STETH accrue in these 2 months or this 1 month or a couple of weeks. But at least in this time, they keep getting the yield from the validator. So it's in their favor at the end. So this is the flow for Lido v3. And now let's go for a bit of context for the bug. So when we do a deposit in the consensus layer, in Ethereum, in EVM, we want to deposit our ETH, to the beacon chain, which means that we send our 32 ETH, we send it to the deposit contract, signed with the validator private key, and also the withdrawal credentials that we have. So if I am a solo staker, I don't care. The private key, I control it. I control the validator. I control my withdrawal credentials. Everything is my control. Everything would work. This is the happy flow. So I just sign with my private key, sign on the withdrawal credentials, deposit it. Everything is good. The sad flow, or what can break, is that there is a pre-deposit front run, which means that before I deposit my ETH, maybe someone else that controls the private key of the validator could front run me with different withdrawal credentials, which means that basically I deposit my 32 ETH, and he deposits, let's say in the same block or the block before, deposit 32 ETH to the same validator, but with different withdrawal credentials. The withdrawal credentials are basically the address, the return address. Where do we send the money after we exit, after we profit, after we get rewards? Which means that if you front run me, this is immutable. So whenever I decide the withdrawal credentials, that's it. So they are fixed forever, which means that you front run me, you had your withdrawal credentials first. Now I deposit my money, you're gonna get it for free. You're gonna get my entire money, my entire 32 ETH, and you just have them. And I can't do anything about it. Because the consensus there doesn't care about a new depositor to different withdrawal credentials, just because if it's immutable, that's it. Then you can't change them. So the fix for this problem, or the partial fix for this problem in the consensus there, is this is the contract, smart contract that shows that they don't care about if it was deposited or not. Trust me, just checks the formatting. So the fix for this is to do the pre-deposit. You deposit only 1 ETH to reserve your space in the beacon chain, beacon layer. You have your validator withdrawal credentials reserved, and then it's pending. It's not active yet because you haven't deposited the full amount that you need, but you still can check that you know exactly what is the withdrawal credentials, that's what you expect, great. Then you can deposit the rest of your 31 ETH to activate the validator, and then you can participate in the staking. This is a partial solution because if you front run this operation, you still can profit the 1 ETH and not 32, but you lose less, but you still can lose 3% and not the full 32 ETH, which is better but not perfect. So if anyone here knows anyone in the Ethereum Foundation, please let's fix this because it's very annoying, both for security perspective and for liquid staking protocols. Lido has a solution for this with the Lido core. It's very cumbersome. It's very, they use oracles, they use a bunch of stuff, but it works for them. Great. So now we know what Lido v3. We know that we deposit, fund the vault. We transfer money to the vault, stake it. We can mint. We can borrow against it. Great. Now what is the problem? Sorry, if this is the pre-deposit. Let's go to the problem because I don't have a lot of time. So basically what happens is that the attacker funds the vault, let's say with 1 ETH. Then we pre-deposit the 1 ETH. We send the money, the ETH to the pre-deposit, to the deposit contract. Then we see that the pre-deposit worked as it should, which means that we can verify on-chain that the correct withdrawal credentials have our ETH, the validator and the withdrawal credentials match. Great. Now we could just mint because as we said, we deposit to the consensus layer. Now we could borrow against it if we want. Let's say we mint 80% of the 1 ETH, we borrow 0.8 ETH, and now we wait. Usually what should happen is that now the attacker should, or the user, now this attacker, should deposit the rest of the 31 ETH to activate the validator. So now it's just pending. It's waiting until you complete the 32 ETH, and now we could start profit. But if you don't deposit the rest of the money, it just stuck. It's just stuck. It just stays like that. It's a pending validator. Nothing bad happens. You don't lose anything, but you don't profit on the other side. If we wait a long time, now the attacker debt is increasing because time passed, the ST increase in value, so it's increase and increase and increase, and then and now we should be able to rebalance the user. We should be able to liquidate the user. Once we liquidate the user, we repay the debt, we draw the stake ETH, we liquidate the debt, we pay the debt, and everything works. But this would not work. Why? Because the Bitcoin chain has this behavior that after you pre-deposit a validator, you can't withdraw it immediately. You need to activate it, and only then you can exit. So you can't exit before before the validator was activated, which means that in this state, the 1 ETH deposited, or even any amount below 32 deposited, is inaccessible for withdrawals. And only when we put the full 32 ETH and activate the validator, and then we need to wait, of course, the entrance queue and everything. Only then we could exit, which means that this money as a collateral is stuck. Imagine you have a borrow position in Aave or in any other lending protocol, and you can't liquidate the position. So that's what happens here. We can't access the collateral. So we have a borrow position, that's position that is that increasing, but we can't repay because we can't liquidate. So that's, of course, not good. And the reason it's problematic is because that this is an unlosable bet for the attacker. Either you want basically to short STETH and long ETH, you think STETH is gonna get slashed. Didn't happen in the past, but maybe it happens. Maybe you think it's gonna happen. So you short STETH, you long ETH, and then either you're right, and then in your leverage position you can just get profit because you borrowed STETH and as ETH as collateral, or you haven't lost yet because I can't liquidate you, which means that either you win or you wait to win. So this is an unlosable bet. So maybe you can't win immediately, but you can't lose also. So of course that's not something we want for the attacker or for anyone. How do we fix this? So the fix for this is quite simple from a logic perspective, but to get to it from design perspective is not easy. Basically, what we do is we fund the vault, of course, with the 1/8 from before. Let's say we mint the 0.8 like before. When we pre-deposit, we stash to the side 31 ETH, which means that when you want to do the pre-deposit itself, you need to have enough money to activate the validator already. You need to have to deposit already enough money to activate the validator. This means that when we prove that everything was okay with the pre-deposit, everything worked, anyone can activate the validator, can force the vault, the staking vault, to deposit the rest of the money and activate the validator, and then we can withdraw it if necessary, which means that here you cannot make your validator get stuck and not be able to withdraw it. And of course, later we wait some time, we attempt to rebalance, and we succeed. Because we can force the validator to exit now, because now the validator is finally activated, and when it's activated, it means that we can withdraw it and we can force it to exit. The most important thing in this bug is that the code was right. So even if the code is perfect, and that's exactly what it's supposed to do, that to do the pre-deposit, and then we need the user to deposit the rest of the funds, and if they don't, they just don't, because that's what the design entails. Even if the code is perfect, we still have this bug. So this bug is in the design of the code, is in the design of the system, and not in the code itself. So it's a very difficult bug to find because the code was right. So even if everything is perfect in the code, even if the team tells you this is what we want to happen, and Lido team are very smart people, this is a very subtle mistake, because everything is worked perfectly, and the collateral exists, and everything exists, but the concrete operation of withdrawing it would not work in the consensus layer in some specific cases. So this was a very difficult bug to notice, because the code was correct. So for summary, so what is Lido v3? We have the vault owner, which is an institutional entity, or any other, if you want, a DAO, or any other user can do it also. You deposit to your staking vault. You could mint directly against their ETH, even if it's staked, so you could profit from that stake, from operating your validator, or doing some agreement with node operator that operates the validator, and you have some agreement with them. And then you could access the liquidity directly by borrowing from Lido STETH and repaying later, of course. In Certora, we offer these services. As I said, design review, which is the process where you look at the code, at the design before the code even exists. Actually, we did this. I did this for Lido for the dual governance mechanism, and we do, of course, auditing for verification, Web2 security. We run validators in Solana, and we have the Certora approval for Rust and Solidity and everything. Okay, great. Thank you, everyone. Thank you very much.